Hey guys, welcome to my tutorial on neuroscience literature mining. Um, so let's go over the background of literature mining. So basically, there are vast amount of research papers available out there regarding the neuroscience field of study. So it's practically infeasible for us to go through each and every paper and find out the correlation between different diseases and their causes. So this task can be easily achieved by using text mining as a tool. So the objective here is to first query the PubMed website and we get all the input files for the text mining, and then we need to develop the text mining algorithm which helps us to find the correlation between the diseases. Then we need to represent those relations using graphs, and that the result is verified, the correlated results is verified by the researchers for their correctness. So the first part is analysis. To do the analysis, we need to acquire the key terms from the researcher and then use the key terms to query the PubMed and extract all the documents. Then we need to compute the weight matrix for those key terms, and then we find the correlation between the key terms by setting a threshold value. Then transitive relation between the key terms is found out if it exists or not. Finally, we generate the graph using this relation. So let's now look at the design process here. So the initial step is to acquire the document and manage it, and then the next step is use the key terms and or the thesaurus for the representation and computation of weight matrix. Then we compute the association matrix by setting a threshold value. Then we use the Warshall algorithm to find the adjacent matrix, and finally we use the graph algorithm to find the transitive relationship between the key terms, and we present the result using association graphs. So the first step is document acquisition and management. So the basic step here is to study the format of the report and familiarize with the structure, and then we acquire the key terms and we query the PubMed website for those key terms, which gives us several documents, and their corresponding document IDs are generated for those key terms, and we extract the documents using the document ID, and the non-relevant information is ignored and the key terms are only extracted, and it is stored in a file for the next step for matrix computation. The next step is documentation, representation, and weight matrix computation. So in this step, we convert each document into structure that contains only text file and the number of occurrence of the key terms which is retrieved. And then an array is created to store all the key terms. A class is initialized to store the number of occurrences of key terms and the key terms itself. Then the array is computed using the following formula, which is wi of k is equal to tik into log n over nk. So here I is the text document, k is the key term, tik is occurrence of the key terms in k file I, and n is the number of total number of files, nk is the number of documents that contains the key terms k. The next step here is to find the association matrix, and we do that by creating an n cross n matrix of the key terms, and we discover the pair of objects which are retrieved from the documents, and we relate one another and find if there is any relation between them. So we use the formula association of ki equals sum of wi of k multiplied by W of I multiplied by I. So here k ranges from 1 to n and I ranges from 1 to n. So k is the kth key term and I is the ith key term, and small I is I document, and I is citation of document I. So the value of association of k of I is positive if there is a relation between the key terms, or else it's 0. So then next step is finding the adjacency matrix. We set a threshold value depending upon our assumption, and we find the proximity between the terms for that threshold value. So if the value of the previously calculated association matrix is greater than the threshold value, then the adjacency matrix is set to 1, or else it's set to 0. So the proximity is either will be either set to 0 or 1 after these steps. So this depicts the relationship between the key terms. It indicates whether there is a relationship between k and I terms or not. So by looking at the adjacency matrix, we can determine whether there is a relationship between the terms. The next step is to find the transitive closure computation. The transitive rule states that basically if x is related to y and y is related to z, then obviously x must be related to z. So we use this transitive rule in terms of the key terms which we have retrieved, and generate more relationship between the key terms. Suppose if one key term is related to another, and that key term's second key term is related to a third key term, so we conclude that the first key term must also be related to the third key term. So such relationships are calculated and concluded by using the transitive rule, and new relations are built upon that. So the final step is the generation of association graph. In this step, we generate and analyze the association graph. We use a tool called GraphViz, which is an open source tool, and we make use of Java to write the code, and so we finally generate a directed graph with nodes and edges, where each node represents the key term, and edge between the each nodes or the key terms between depicts the shows the relationship between the two key terms. So we find the frequency of occurrence of that particular key term. So now we come to the last part, which is area of exploration, which is basically where all in which all domain the neuroscience other than neuroscience, where the text mining can be explored. Then the next thing is we can increase thesaurus and search for more domains, and last approach is to develop a multi-agent based system. So these are the references, and thank you for watching the tutorial. Thank you. Bye bye.